right, so now we are ready to go in and do the application and go in and turn nominal gross domestic product into real gross domestic product. So just as a real quick review on the last video, what we finally decided is that we can calculate the consumer price index for any given year by going in and taking the cost of the market basket in the year that you are calculating for, divided by the cost of that same market basket in your base year, and then going in and multiplying that number by 100. And so by doing that, then we can look and see how much average prices have increased from the base year to the current period. All right, the nice thing about this is the Bureau of Labor Statistics has already done all of these calculations for us. And in fact, under your course content shell, you should print off there's a file called the Consumer Price Index 1913 to 2016. And when you print that off, this is going to be the sheet that you're going to see. So what I want you to notice is we have our years here going from 1913 all the way down to 2016. So the first column is going to be your year. The second column is going to be the actual value of the consumer price index itself. So if we were to go in and we were to do this calculation, then we would come up with the numbers for the consumer price index that you have in this second column. All right, and we're going to be using those numbers here in just a little bit. Now, the other thing that I have given you is the third column is going to be your year-to-year percentage change. Remember in the last video I told you that the consumer price index is not to be considered a rate of change. It is not a year-to-year change. It is only to be interpreted from the base year to the current year. But there are some people that ask, well, how do I know how much average prices have increased from one year to the next? And there is a formula. They give it to you in your book that you can go in and do that conversion. We're not going to do that, but what I have done in an Excel is used that formula, and then I've gone in and I've created this year-to-year percentage change. So I just want you to understand that's for your own benefit. We are not going to use any of these numbers in any of our calculations. The only ones that you will be using will be the consumer price index itself. All right, and the other thing I want you to notice, and we're going to be staying with this for the rest of the time period, is going in and notice that your base year for this entire thing is 1984. So 1984 is equal to 100, so that is going to be the year that prices are going to be held constant. So remember, back when we were doing the last part of our calculations, if you were to look at this table of numbers and ask, well, let's say for 1980, no, that's wrong, let's go a little bit further down. Let's say for the year 1990. If I were to ask you what is the consumer price index for 1990, then you would simply tell me it is 130.7. Remember, it is not a percentage and it is not a dollar value. So, how much have average prices increased from 1984 to 1990? Remember, you go in and you take your consumer price index, you subtract off 100, and that will turn that into a percentage change. So in this case, you have the number 130 minus 100. I'm sorry, 130.7 minus 100. So you come up with the number 30.7%. So you would tell me that average prices have increased 30.7% from 1984 to the year 1990. All right, does that make sense? So if we go down a little bit further, then if I ask you what is the consumer price index for the year 2000, then you would look at this and say the consumer price index is 172.2. And so you would take your 172.2, you would subtract 100, and you would get that average prices have increased 72.2% from 1984 to the year 2000. Okay, so that's how you go in and you use this interpretation, even though it looks a little bit different because we're not actually doing the calculation itself. The interpretation is done exactly the same. Now, by the way, I want you to go in and look at these numbers for just a moment. So a lot of people ask, well, can average prices ever go over or be greater than 100%? And the answer is yes, they can. Go down and look at your consumer price index for the year 2006. So your consumer price index is 201.6. Well, again, if you take 201.6 and you subtract 100, then you get 101.6%. So that would tell you that average prices have more than doubled. So it's been 101.6% from 1984 until the year 2006. How much have average prices increased from 1984 until the year 2016? That is correct. You take 240, which is your consumer price index, you subtract 100, and you'll get 140% from 1984 until the year 2016. Which, and then some people say, oh, okay, I see how that happens. Well, can the consumer price index ever go over the number 300? And I think the answer is clearly yes. We've already, from the year 2006 until the year 2016, so that's a 10-year period, we've gone from 101 all the way up to, 201 all the way up to 240. So yes, it is definitely possible and probably actually will by the year 2030, those numbers will be reading somewhere in the 300s by the time we're all done. Okay, so that's how you go in. That's what these numbers represent. So the Bureau of Labor Statistics has gone in and they have already done all of this work for us. So the question then becomes, all right, since we want to go in and since we want to actually change, okay, let me back up. We now know how much average prices have changed because that is measured by the Consumer Price Index. So what we want to know is, how do we go in and use those numbers to actually go in and convert a nominal to a real value? All right, and the answer is we're going to use this equation right here. So any real variable x, and I'll explain what x means here in just a moment. So any real variable x is going to be equal to your nominal variable x divided by the appropriate consumer price index, which is where you're going to get those from that chart up here, and then you're going to multiply that by 100. Okay, so first things first then, and I've made this equation very generic for a reason. Because yes, we started out with the idea of X being equal to gross domestic product. X being equal to gross domestic product. And we're going to do, that's one of the first ones, calculations that we're going to do here in just a moment. But it also turns out you can use this same formula to go in and convert nominal spending into real spending. You can convert the nominal wage into a real wage. You can convert nominal consumption, PTION, saving, and any other variable that you want to put into this equation, you can, and that will go in and convert it from a nominal over into a real value. So that's what's really nice about this is you only have to have one equation to go in and do all of these calculations that we are going to do. All right, let's go in and let's take a quick example. First of all, let's go in and let's say that 1984 is equal to 100. Now, what I want you to understand is that's a very important piece of information because you notice the numbers, we're going to have a consumer price index number, and that consumer price index number is going to have to be based in 1984. And it just so happens that that's what these CPI numbers are based in. So what that means is that gives me the right, it gives me the license to use these consumer price index numbers in the calculation that I'm about to do. So if I were to tell you, just for an example, that 1990 is equal to 100, then you could not use these CPI numbers in your equation because these are based in 1984. You would have to go to another sheet of paper and you would have to have one that says 1990. Is that what I said? 1990 is equal to 100, and then go in and get those numbers off of that sheet. So that's an important piece of information. Some people see it as trivial. It's not, because that gives us the right to go in and tells us what CPI numbers that we need to use. Okay, so again, 1984 is going to be equal to 100. All right, let's go in and let's give you the information that nominal gross domestic product in 2003 is going to be $8,362 billion. Okay, so what we want to know is what is real gross domestic product in 2003. Okay, so here's what we're going to do. We're going to start out with this very simple generic equation, and we are going to make it very specific to the question that we have at hand. So according to this, our real, and our X is going to be gross domestic product because that's what we're calculating for. So my equation will be real gross domestic product in the year 2003 is going to be equal to my nominal gross domestic product in 2003 divided by the appropriate consumer price index in 2003 multiplied by 100. So this is the very specific equation for this up here. All right, so let's go in and let's plug our numbers in. So according to this, we have nominal gross domestic product in 2003. I gave you that information right there. That's the thing that we actually measure out in the economy. So we have $8,362 billion divided by the consumer price index in 2003. So we're going to go back to our sheet. We're going to find the consumer price index in 2003, which is going to be this number right here, 184. All right, so we come back down here and we plug in the number 184, and then do not forget to multiply it by 100. So if you plug that into your calculator, our gross domestic product in 2003 will be equal to your 8362 divided by 184 is going to be $4,544.6 billion. And that is your number for your consumer price index. Okay. So a lot of you, hopefully you're looking at that. Okay, first of all, I hope you followed along with the equation. If not, let me know. But we're going to be doing a couple of more examples here, so you should get the hang of it here fairly quickly. I think, though, a lot of people look at this and they think to themselves, well, I was hoping for a little bit more of a hurrah out of this whole thing because this is the third video of doing this. I expected a little bit more fireworks and things like that. But I don't want you to miss exactly what has happened here. Remember, our entire problem to start was that we had both price and we had quantity changes that were going on at the same time. That was the problem. So what we wanted to do is come out and have prices being held constant where we're only going out and measuring changes in quantities, right? That was the goal of going in and doing all of this. Okay, I want you to go back and I want you to look at this very generic equation that we have up here at the top. And I want to concentrate just on this part right here. Because I want you to remember, and again, in our case, we were doing nominal gross domestic product. So in the numerator, you had both price and quantity changes, P times Q, that was going on at the same time. All right. In the bottom, the consumer price index is a measure of what? It's correct. It is the measure of prices in the economy. So if you have this equation, what happens to the P's? That's right. They cancel themselves out. And so all you're left with is the change in quantity, which is what we were looking for in the first place. So by going in and dividing this by the consumer price index, and in fact, you have canceled out the price level changes that have taken place. And in doing so, we have gone in and we only have a measure of quantity change that is left at the end of the equation. Okay, so hopefully that makes sense. And it's a very important thing to understand, exactly why this equation works the way it does. Okay, let's go in. Let's do another example to get just a little bit of a feel for what this is doing. All right, so let's go in, and again, I'm going to tell you that 1984 is equal to 100. All right, let's assume that we have a student. Let's say that student spends $90 a month on beer in 2003, and this amount has increased, hopefully not because of this class, to $110 per month in 2011. Okay, now I want you to notice exactly what we have going here. If I were to ask you the question, and listen to this carefully, in nominal terms, has this person spent more money on beer between 2003 and 2011? And the answer is yes. According to this person physically took $90 out of their pockets and purchased beer in 2003, and they physically took $110 out of their pocket in 2011 to purchase beer. All right, so in nominal terms, it looks like we have an emerging alcoholic going on here. But my question is, in real terms, did this person spend more money on beer? All right, the answer is, at least right now, we don't know, because we're trying to go in and compare two nominal values against each other. And what you have to understand is you can only compare real values that have the same base year. So when you go in and you have two nominal values like this doesn't really give us any information at all. We want to know, did this person really consume more beer? So here's what we're going to have to do. To find that out, we're going to have to do two calculations. We're going to have to go in and we're going to have to calculate real, and let's just call it spending, in 2003, and compare that to real spending in 2011. And then see how those two numbers are different from each other. All right, so we already know if we go up, that should be a 100 there. All right, so I'm going to go ahead and set it up for my equation. So we know that real spending in 2003 will be equal to nominal spending in 2003, which is going to be $90, it's that number right there, divided by the consumer price index in 2003. Again, in this particular case, that number is going to be 184. All right, so let's take that back down, and we're going to plug 184 down into this. Okay, so if you take 90 on your calculator divided by 184, and then multiply it by 100, you get real spending of $48.91. Now, what I want you to do is pause the video and calculate real spending in 2011. Okay, now that you've done that, according to this, real spending in 2011 will be equal to your nominal spending, which is going to be $110 a month, divided by the consumer price index in 2011, which is going to be this number right here, which is 224.9. So let's go back down here and 224.9. And if you take 110 divided by 224.9 multiplied by 100, lo and behold, you're going to come out with $48.91. When you're dealing with everything but gross domestic product, always go in and round to the second digit because this is a dollars and cents problem. Okay, so this clearly says then, when you go in and you look at, hey, was this prices or consumption that was going on? The answer is it was all prices. Because once we turned it into a real variable, the prices remained constant. We were only measuring consumption. And in this case, consumption stayed exactly the same from 2003 to 2011. So this gives us a very, very good way to go in and compare these two monetary values with each other. Okay, let's do one more problem. This is going to be one that you're going to have to do on your homework. I probably mentioned in class a couple of times that I like to talk to older people because you really don't know how good or bad you have it until you hear what it used to be back in the good old days. And there was a gentleman I was talking to a while back that made the comment that, I feel sorry for you younger people. I'm like, well, why would that be? And he said, well, you no doubt have a much larger paycheck than I used to have. And this person's working lifetime would have probably been back in the 40s, 50s, and 60s. But he said, it just seems like your money doesn't go as far as it used to. Well, that's an astute observation, but we can actually go in and show that that is really the case. All right, so let's go in and let's do 1984 is going to be equal to 100. All right, now what we can show is if you go in and you look at the nominal wages, historic nominal wages for two different years, you see that in 1964, the nominal wage was equal to $2.50 per hour. So to go in and calculate an individual's wage, you would take 250 times 40 hours a week times 52 weeks out of the year, and that's how large their income would have been. But by the time we got to the year 2012, then nominal wages on average were $19.57 per hour. And that is clearly much, much larger. In fact, if you were to look at people's paychecks, they were actually, it appeared that they were making, and in fact, in dollar value, they were $17.07 more in 2012 than they were in 2014. The question, though, is, were we $17 better off as far as consumption was concerned? So what I want you to do in just a moment is to go in and calculate the real wage for 1964 and compare that to the real wage in 2012. And then go in and tell me, did that wage increase or decrease, and by how much? Pause the video now. Okay, so if we go in, and I'm going to go ahead and draw my lines here so I can just simply fill in the blanks. All right, so if we calculate our real wage for 1964, then we know that is our nominal wage, which is $2.50, divided by the Consumer Price Index in 1964. So go to your sheet, and you'll notice right here, the Consumer Price Index was the number 31. Okay, let's scroll back down here so we get the number 31. So if you plug that into your calculator, $2.50 divided by 31 times 100, the real wage in 1964 was equal to $8.06 per hour. Okay, for the year 2012, we know that the nominal wage was $19.57 per hour, divided by the Consumer Price Index in 2012, and let's not get this all messed up here. So the Consumer Price Index in 2012 would be 229.6. All right, so let's go down here at 229.6. All right, go ahead and multiply that division by 100, and you come out with $8.52 per hour. Okay, now two things I want you to notice. Number one, the real wage did increase. The real wage did increase because we were making $8.06 per hour. Now we went up to $8.52 per hour. So the real wage did go up. We're better off than what we were in 2012. But instead of being better off by $17 per hour, if you take your $8.52 minus $8.06, we were only better off by 46 cents per hour. So our paychecks were going up $17 per hour, but we could only buy 46 cents more goods and services than we did back in 1964. So the gentleman's observation was correct. Our paychecks are a whole lot bigger than what they used to be, but you know what? They just don't go nearly as far as they used to, and that's because prices are going up over time. So use this as a model on one of your homework assignments. But you want to remember the key to this is use this equation, write the equation out with your years and so on, so you know what you're plugging in, And always keep in mind, nominal values stink. We can only go in and you can only compare two real values that have the same base year.